Hello, this is the second part of the part 3 of the video series on solving inequalities. Here, we'll look at some more examples on two variable inequalities. Here in example 1, we have to write the inequality that describes the shaded area. So what do? We need to first determine the equation of this line. So how do we get that? We have 2 points where the line passes through. Depending on which method we want to use, we can write the equation using the equation of the line y equals mx plus c. So we know the intercept for sure as 6, because that is where the line cuts the y-axis, but I need the gradient. So if I calculate the gradient using m equals y2 minus y1 over x2 minus x1, if I call this my point 1 and I call this my point 2, it doesn't matter which one. You can call this 1 and this one 2, it doesn't matter. You get the same thing. So m will be, so y2 here will be 0 minus y1 will be 6 divided by x2 will be 2 and x1 will be 0. So it means that m will be minus 6 over 2. So m will be minus 3. So you can see that the gradient is minus 3. So I can write the equation of the line as y equals minus 3x plus, because the intercept is 6, so c is 6. So the equation will be y plus 3x equals 6. I can write it that way. So because this line is a broken line, we know that it's going to be either greater than or less than, but there will be no equals to it. But if the shaded region is the solution, then it means that I need numbers that are less than 6, because if I go, that means it's going to be y plus 3x less than 6. Because if I go up, then I will meet numbers that are greater than 6. The solution, if you substitute any value for x in this region, the value of y that you get will be less than 6. That's what this means. So it will be less than, no equals, because there will be no equals because the line is broken. Okay, so that's the solution. If you want to write it in set notation form, you can write it as x comma y such that y plus 3x is less than 6. This is another way you can write it if you want to write it in set notation form. Okay, so let's look at another example. Example 2, show the solution of the simultaneous inequalities graphically. So you want to show the result of the solution of this on a graph. To do this, we should be able to plot the lines on the Cartesian coordinates. Then we shade the appropriate region based on the inequality. So I would advise you first write the inequalities in the manner that you have only y appearing on the left. So if I want to write this such that I have y appearing on the left, so it's going to be y greater than or equal to 2x minus 2. So because if 2x minus 2 is less than or equal to y, it means y will be greater than or equal to 2x minus 2. Then for the other part, if I want to write y on the left alone, that is, I want to make y the subject, then I will have 2y less than or equal to x plus 2. Then if I divide both sides by 2, then I will have y less than or equal to x plus 2 over 2. Now, I know that the sign, the appropriate sign, I can then plot the line on the Cartesian coordinate. So if I want to plot the line, let me plot the line here. So now when x is this, that means I need to represent this on the graph, y equals 2x minus 2. This is the line that I want to draw. And I want to draw this line, y equals x plus 2 over 2, basically. So this inequality sign is just to know the appropriate area to shade. But you actually we are actually plotting the equation of this line. I'm actually plotting this line on the graph. So how do you get the 2 points that the line will pass through? So we need 2 points. So when x is, the best way to do it is, okay, you can get the y-intercept. At the y-intercept, x is 0. So you say when x is 0, then I can get what y will be. So y will be 2 into 0 minus 2, and y will be 0 minus 2, y will be minus 2. So I know that, oh, this line passes through minus 2 somewhere here. So if this is minus 1, and this is minus 2, then it passes through this point. Then I need one more point to be able to draw the line. So that one, I can get it at the point where the line cuts the x-axis. So on that x-axis, y will be 0. So when y is 0, I can get what a value for x. When y is 0, what will x give us? 0 equals, so I'm replacing y with 0 here, equals 2x minus 2. Then if I move 2 to this side, 2 is 2x. Divide both sides by 2, then it means that x equals 1. So that means this line also passes through 1, 0. So this is 0 minus 2, and this is 1, 0. So I can draw the line now. So the line will pass through here. But okay, it's a continuous line, so I'm fine. That's the line. It's continuous because it has equals. Then where do I shade? Then I go to the equation, the inequality. I check for the sign, y greater than or equal to. That means I need numbers that are greater than or equal to whatever value of y I have here. So I need to go up. If it is greater than or equal to, I need to go up. So for any value of x that I choose, then my value of y will be greater than minus 2, basically. Yeah, which means if I put x as 1 here, y will be 0. So that means I'm going up. If I put x as 2 here, y will be 2. I keep going up. So this is the solution for that part. Okay. Now let's plot the other line. So for this line, when x is 0, so what is y? If I put 0 here, y will be 0 plus 2 over 2, which is 2 over 2, and that's 1. So that means I have 0, 1 as one of the coordinates. So it means that for the second line, let me use another color for that. So it passes through y1 and x0. So this is this part, this is 1, so this is 0, 1. I need one more point. So when y is 0, what is x? So if I put 0 here, 0 equals x plus 2 over 2. So if I cross multiply, 2 times 0 is 0, 0 equals x plus 2. That means x will be minus 2. So I have minus 2, 0. So I can plot that. I can plot the second point. So this is minus 1, and this is minus 2. So this is a point. So that means that line will be this. Okay. That's the second line. So where will I shade? I go to the inequality, I check. I have less than or equal to. That means I need regions that are below the line. So I have to shade below the line because I have less than. The solution will be this region. You can see the intersection of this line. So the solution is basically this region that looks like a triangle here. You can see that? So that's the solution of the inequality. Okay. So let's look at another example. That'll be the last example. So we have to draw the graph to show the region defined by all the three inequalities below. So you have to shade the required region. So I need to plot each of these on the Cartesian coordinates. So for the first one, y greater than or equal to x minus 1. So that means I need to write the equation y equals x minus 2, sorry, x minus 1, when x is 0, what is y? Y will be 0 minus 1, y will be minus 1. So that means I have one coordinate, that one point where the line passes through, which is 0 minus 1. I need one more point. So when y is 0, then if I go back to the equation, when y is 0, I put 0 here. What is x? X minus 1. So if I move this one here, 0 plus 1 equals x, it means that x equals 1. So I have another point 1, 0. So I can plot the graph on the Cartesian coordinates. So I have the point 0 minus 1, x is 0, y minus 1. So minus 1 will be here, x is 0 on the y-axis. So I have one point. Then I need another point when x is 1, y is 0. So and then if x is 1 here, y is 0. This is the point. Then I can plot the line. Okay. So that is the point. So because it is greater than or equal to, then I have to make it a continuous line. So where do I shade? Greater than. So I go to the inequality. So I need areas that are above the line. So greater than, above the line. So I go up, so I'm shading that. So that's the region defined by that inequality for this first one. Greater than or equal to, because it's equal, that's why the line is continuous, it's not broken. Then for the second one, I need to rewrite it in the form that y will appear on the left alone. So if I want to do that, I will have 5x plus 6y less than or equal to 30. So 6y will be less than or equal to 30 minus 5x. So y will be less than or equal to 30 minus 5x over 6. So this is the equation I want to use. Y less than y equals 30 minus 5x over 6. Now, when x is 0, what is y? Y will be 30 minus 5 into 0 over 6. So y will be 30 over 6, because 5 times 0 is 0, 30 minus 0 is 30. Then that will give me 5. So I have a coordinate there, and that will be 0, 5. Then I need one more coordinates to be able to plot the line. I can get that by setting y to be 0. So when y is 0, then I go to this equation, 0 equals 30 minus 5x over 6. If I cross multiply, then I have separated 0, x times 0 is 0, 30 minus 5x. Then I move this 5x to the other side, 5x will be 30, divided by 5. Then x will be 6. That means I have another coordinate 6, 0. Then I can plot that line. So when x is 0, y is 5. So that will be, let me use another color here. So here, 5, 0, there is 1 point. And when x is 6, y is 0. So x is 6 will be somewhere here, y is 0 on the axis. I can plot that line. I plot the line, and I have that line. It's also continuous because there's equals there. So how do I shade? I go to the region that has the equation that has the equality sign. Like basically, I look at the inequality. I have less than. That means I'm going to shade below the line. So I shading below the line because it's less than. Okay. So I shade that. Now, I need one more inequality to show x greater than 1. That means I need region that is greater than, for x greater than 1. I need to plot x equal to 1. So how do I show x equals 1? It's going to be a vertical line. Let me use another color, blue, a vertical line that passes through 1. So that would be, oh, sorry. I made a vertical line that passes through. So that's that. And where do I shade? Greater than 1. So I need numbers that are greater than 1. So I need to go in this direction. So this is the direction where I'm going to meet numbers that are greater than 1. So the solution has come out. So we have a boundary. Let me use another color to show the region that represents the solution. So that will be the region cut out by these 3 lines. You can see that by this line. On this black line, on this blue line, and on this red line. So you can see the triangle. So that is the solution for the 3 inequalities. I hope that is clear enough. So we'll stop there and I'll see you in the next part of the video. Thank you and bye-bye.